So I have my KDF. This is my Koala's data frame. So I come down here, I'm going to convert it to a Spark data frame. And then I'm going to, from PySpark, I'm going to import a regressor. I got to do the vector assembler, and then I'm going to do a regression evaluator. And so, the vector assembler is, it's going to be what puts my data in the format I need for PySpark. I mean, for PySpark MLlib process my model, right? That's what vector assembler is doing. This is the algorithm I do, is regression. I don't know if it's, and then this regression evaluator is what's going to evaluate how well my model did, but it's coming from the PySpark library, right? And then this, like I said, this vector assembler says, hey, take my input columns and input them and then output them as this feature column. And then I transform it and put it together, and then I can split it up, and then I run my regressor against my, so notice it's the feature columns. I'll output this to make more sense. The features and then label column, this is my Y, right? And then I fit my model, and then I get my predictions, and then I evaluate how well I did, right? So let me just go run this. And then when you see the output, it'll make a little more sense what each thing's doing, right? But this is, this is how we have to work with PySpark. It's a little different, right? It's not quite as simple as like scikit-learn, but if I had 800 million rows and I had a cluster with 32 nodes, I could run this and it would run in in a few, however long it'd be, I don't know, 20, 30 minutes maybe. So splitting 730, right? So here's my, so I got a Spark data frame. I'm gonna work on it. So this vector assembler. So if I look and I show you what that looks like, you can see where it did this vector assembler. So see where it created this features column here, and you see where it created this kind of like list, right? We had to set this up so that we have this, I keep pointing to the screen, the people online can't see where I'm pointing. So that's what we have. And so when I go and call it, I pass the features column as my X's, and I patch the label column as my Y's. So this is my feature column. These are my 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 X's as this one column put together in this one list. And then I have my quality, which is this one right here. And so I put that in, and then that gives me my vector assembled data frame. And then I split that up in the training and test. I go and fit my model, and then so I train it, and then I can do my predictions, get my tests, and then I can evaluate my model using the regression evaluator, and then I get like my root mean squared error, right? So then I come down here and see it was 0.06, and then I can do some things. So I can convert back I can use this Koala data frame thing to convert back my predictions from the Spark data frame to Koala's data frame, so that I can then do things at scale to against using the Panda syntax. So now this is just showing me, this is what the prediction was, this is what the quality actually was, and then it plots out this cool plot where you see the red is the prediction, blue is the quality, and so we can kind of see graphically how well we did. But this was done using the PySpark and using MLI. This would scale. So if you were to go and had some money and spin up a big cluster and put 200, 300, 400, 800, a million, billion rows, this would run and scale. And you can use the MLlib and PySpark to do that. You go try to do a billion rows in Panda data frames against scikit-learn, it might run. If you have a big enough server, it probably will. And billion's not as big as it used to be. That's not really big data. Trillions and petabytes are starting to get into big data nowadays. But that being said, you can see what we can do. So that is Koalas. So the main point of takeaway of Koalas is I use the Koalas package, and I use the same APIs I use for Pandas, but it's a Koalas data frame, and it's Spark aware, so it goes at scale. And then when I want to actually use it against PySpark, I just have to convert it with the 2Spark, right? That's just function built into Koala. So then it gives me my Spark data frame. That's what, in this case, what I'm calling SDF. So that's that one. Right with me there? So we just basically build a regression algorithm, but using the ML from PySpark. And we can do this. This is, if I had multiple nodes, you'd see the job spread out across the multiple nodes and go fast.